Good day, everyone. Today we are talking about section 1.5, solving linear systems algebraically. So our three learning targets for today: I can determine if a coordinate point is a solution to a linear system of equations. I can solve a linear system of equations using substitution. I can solve a linear system of equations using elimination. So what's going to happen? Oh, we got off our slide here. Just give me a moment. All right. So it's the first part here is determine if the given coordinate point is a solution to the given linear system of equations. So in other words, is the answer correct? So basically this is just checking. So first one, we're going to take this, and again it's written in alphabetical order, so our variables are x and y. So we're going to go 3 times 2 minus 4 times negative 1. Does that equal 10? So we go 6, and then we've got negative 4 times negative 1 is plus 4, is 6 plus 4, 10. It works in the first equation, so that means we're going to go and check the next one. It needs to work in both of them to be a solution of the system. So we're going to go 2 times 2 plus 3 times negative 1. Does that equal 1? Well, 2 times 2 is 4. 3 times negative 1 is negative 3. Is 4 minus 3 equal to 1? Yes. Since they both check, our answer is yes. It is a solution of the system. When we look at the next one, so we're going to check it again, x, y, coordinate point in alphabetical order. So 3 times negative 4 minus 4 times negative 2, does that equal 4? So we get 3 times negative 4 is negative 12. Negative 4 times negative 2 is 8. Does negative 12 plus 8 equal 4? No, because this would be negative 4. Doesn't work. So right there you can say it's not a solution or no. Again, it has to work in both equations. I don't even have to check the second one because it doesn't work in the first, so it doesn't matter. All right. The first method or technique we are going to talk about for solving systems is substitution. When would you use substitution? When a variable has a coefficient of 1. The biggest issue I hear from teachers with systems of equations are like, students know and can remember how to do substitution, they just don't remember when. So the big thing with substitution is you want a coefficient of 1. If you have a coefficient other than 1, you're not going to use substitution. It's just too messy. All right. Now, one thing about solving systems, it helps to be neat and a little bit organized. Otherwise, these can become a real mess. So the first thing we need to do is we are going to identify where our system has a coefficient of 1 because we want to use substitution. And that's right here. It doesn't have a coefficient written, that's implied to be 1. So what we're going to do, the first thing we're going to do is get that variable by itself. So we're going to get x equals. So just like we did in section 1.4 with rewriting formulas and solving for a variable, we want to get x equals. So we are going to subtract 2y so that we get x equals negative 2y minus 5. Once we have done that, we are going to take this and plug it in the other equation for x. This is what's called substitution. Just like in section, I think it was 2, where we were plugging in for a variable, and then we were plugging in a number. Here we are plugging in an expression. So we are going to say that we have 3 times, and again, we're plugging in for x, so we're going to put it in parentheses, negative 2y minus 5 minus 4y equals 25. So in other words, I'm taking the bottom equation and putting it in, or substituting it into the top one for x. Now, since we have a set of parentheses, we're going to distribute. So we have negative 6y minus 15 equals, oops, sorry, minus 4y equals 25. We have like terms on the left side that we need to combine. So we're going to combine our like terms here. So those two like terms we're going to combine. So get negative 10y minus 15 equals 25. We now have an equation with only one variable, so we can solve this equation. We're going to add 15 to both sides. Divide by negative 10. And we get y equals negative 4. We have now found one of our components. Now we can go back into, we can use this equation, we could use that equation, or we can use that equation to solve for x. Personally, the one that's x equals is the easiest. So I'm going to go x equals negative 2 times our y value was negative 4 minus 5. See, negative 2 times negative 4 is 8 minus 5. X equals 3. Now, when we are solving system of equations or system of linear equations, our answer is not just, oh, x equals 3, y equals negative 4. We need to combine these and make these into a coordinate point. So we will write this, our answer, as 3, negative 4. There's our answer. Now, going back and rereading this problem, it says check your solution. Just like we did in section 3, when you're checking your solution, you need to show that it works. In other words, like we were doing when it said, is the coordinate a solution of the system? We're checking, does this actually work in the original problems, that in the original equations? That's what's different about checking. You have to use the original equation. So I'm going to go 3 times 3 minus 4 times negative 4. Does that equal 25? Well, that's 9. Negative 4 times negative 4 is positive 16. Is 9 plus 16 equal to 25? Yes, it works in the first one. So then we go 3 plus 2 times negative 4. Does that equal negative 5? So 2 times negative 4 is 3 minus 8 equal negative 5. Check, it works. It is very easy to make a simple mistake when doing systems. So it is very important to check, because if it doesn't check, that's an indication you made a mistake. So go back and check your work. A lot of times it's a matter of, oh, I screwed up a negative and a positive here, and then you can go back and just change a couple signs and you don't have to start all of the work over. If you solved for x incorrectly, like you put negative 2y plus 5, then I'm sorry, you're going to have to kind of pretty much redo everything. Again, check your work. Even if it doesn't say to check, you should check your answer to make sure it's correct. All right. If we're not using substitution, we're using elimination. So when the coefficients are not 1, basically anytime you don't use substitution, you're using elimination. I personally prefer elimination because I find substitution gets to be messy. When you go, oh, I'm going to plug this in here and that, and I tend to make more mistakes with substitution as compared to elimination. Okay. The big thing when doing elimination is that you need to get one set of opposite coefficients. And I'll explain that here in a sec. All right, so our system here we've got, and again, it's not always going to be X and Y, but the big thing is you use alphabetical order. All right, so when I look at this, I can pick whichever variable I want. So whether I want to eliminate C or eliminate D, it doesn't matter. The big thing is what I'm going to do is I'm going to multiply the entire equation in order, one equation by one value, the other equation by another, so I can get that variable with opposite coefficients. So what I'm going to do is I'm going to pick D, because I'm like 3 and 2, I know they both go into 6. So what I'm going to do is I'm going to take this equation, and some people like to do parentheses, go, okay, I'm going to multiply this equation by 3. And so I'm going to take 9c times, or sorry, 3c times 3, negative 2d times 3, and then equals, and then negative 8 times 3. So I multiplied the entire thing by 3. Now, when I'm doing D, I want to get the, or I'm sorry, the second one, I want to multiply that I can get the opposite of negative 6. So I want positive 6. So what do I need to multiply negative 3 by to get positive 6? I need to multiply by negative 2. I would like you to show what you are multiplying, because A, I can identify, or you and I can make an identify if you made a mistake here, or we can check your multiplication easier to see did you multiply correctly. All right, so I'm going to multiply everything by negative 2. So I'm going to get negative 8c plus 6d equals positive 14. All right, Mr. A, I did a lot of work, but it doesn't look any better than it did before. It actually looks worse because the numbers are bigger. The elimination method, what we did is we are converting or multiplying to a fact that we can eliminate. What we're going to do is we are going to add these new equations. So I'm going to take 9c plus negative 8, and I get a positive c, or 1c, however you want to write it. And here, negative 6d plus 6d, those cancel. They eliminate each other. This is the reason you use this method, and the number you chose the numbers that you did is so that one variable gets eliminated, so we only have one variable left. Negative 24 plus 14, negative 10. We have now solved for C. We are now going to take this and plug it into any of these 4 equations. It is your choice. I'm just going to use the first one. So I'm going to go 3 times my C value minus 2D equals negative 8. So this was negative 30 minus 2D equals negative 8. And then I'm going to solve. So negative 2D equals 22. Divide by negative 2. And I get D equals negative 11. Just like before, coordinate point, alphabetical order. So C goes before D. Again, it says check your solution. So we are going to go and check. So 3 times negative 10 minus 2 times negative 11. Does that equal negative 8? So we get negative 30 plus 22. Does that equal negative 8? Yep. And then we're going to go 4 times negative 10 minus 3 times negative 11. Does that equal negative 7? So we get negative 40 plus 33 equals negative 7. It checks. Circle my final answer. And we've now solved this system using elimination. All right. We are going to do a bunch of these in class, and we will do as many as it takes for you to feel comfortable with these problems. When it comes to word problems, you can solve it using whichever method you want. Usually the hard part on these is writing the system. And when you go to write a system, a lot of problems are different. There are some that are very similar, like in class we'll go through a couple more examples. Here we're talking about investing money in a bank. We're also going to talk about ticket sales. I'm just going to put this out here. I'm either going to do the investing or the ticket sales problem on the test. So as long as you have an understanding of how these two types of problems work, you will be okay. All right, so this one says a total of $1,150 was invested. Part of it at Bank A at 12% interest and part at Bank B at 11% interest. The total yield or interest earned was $133.75. How much was invested at each bank? Okay, I'm just going to use the letters A and B because that's what the two banks are here. So we know the amount we put in. So I'm going to say we have an amount line, and that's that A plus B equals 1150. The amount we invested between the two banks is $1,150. That's where it says a total was invested. So if you don't want to call this the amount, you could call this the total line. Like this could be, like if we're talking about tickets, total number of tickets sold. All right, and then we're going to have what I call the money line. And in this case, it's money earned. At Bank A, we earn, actually I'm going to switch colors here. At Bank A, we got 12%. And again, remember, we don't use percentages in formulas, we convert them to decimals. So at Bank A, we got 0.12. At Bank B, we got 0.11. And that equals 133.75. Now, how you go about solving this, can you use substitution? You bet. You can solve the top one for A, you could solve the top one for B and substitute it in that red, that money earned line. Could you use elimination? Yes. If you were going to use elimination, what I would do is multiply this red one by 100 to get rid of the decimals, and then multiply the top one, the green one, to get your opposite coefficient. What I'm going to ask you to do is to pause the video, pick a method, and solve it using substitution or elimination, and then come back and check. All right, so I have done it both ways here, and I'm going to walk through and explain both of them. So I'm going to do substitution first. So that's what I did here on the left side of the board. So I started with the fact that A plus B equals 1150, and then I subtracted B from both sides. And then I wrote A equals 1150 minus B. I then took that and substituted it. So if you want to think about it, I took this and put it in to the red equation, the earned one, instead of A. So I have 0.12 times 1150 minus B plus 0.11B equals 133.75. I distributed, I collected like terms, so here are my like terms. I then solve, so I subtract the 138, divide by the negative 0.01 to get B equals 425. Once I have that, I plugged it back into my equation in black here where it says A equals 1150 minus B. So then I subtracted 425 from 1150 to get 725, which gives me my final answer right here. That is if I did substitution. If I did elimination, I scroll back up here. So the elimination I did here on the right side. So as I mentioned before I paused, since I had decimals, I'm like, I don't want to deal with decimals. So I multiplied everything by 100. Why 100? Because I have two numbers after the decimal place. If I only had one, I would multiply by 10. If I had 3, I would multiply by 1,000. So for each digit that there is behind the decimal place is another power of 10. So 10, 100,000 that we're going to multiply by. Usually there's going to be 1 or 2 decimal places. I'm not going to give you anything with 3. But anyway, so I multiplied. I had 12a plus 11b equals 13,375. Now I need to figure out which coefficient I want to cancel. I chose b. It doesn't matter. You could do a. I just chose b. So in order to cancel out 11b, I have to multiply the green one by negative 11, so I get a negative 11b. So then I multiplied a times negative 11, b times negative 11, and 1150 times negative 11. And then again, I'm going to add the two equations. So negative 11 plus 12 is 1a, and then negative 12,650 plus 13,375 is 725. And I have 1a equals, so therefore I found one of my answers. Again, once I have A, I can plug it into either the green or the red equation. It's my choice. I chose to do the green one because the coefficients are 1. It's easier. And I solved it and got B equals 425. Notice I got the same answers either way, so it is personal preference on which way you do it. If you have any major questions on this, make sure you are asking. Otherwise, have a great day, everyone.